SwayamPrabha. Digital India. Educated India.
Welcome back. In lecture 32, we will talk about sanitation basics, part 2. The concepts that we will cover in this particular lecture are sewage project plans, city sanitation plans, sanitation and health, and then we will talk about different data requirements and service. So, when we talk about any kind of sewage projects or when we plan for projects, then we can think in different time periods. So, we can think of short time periods, medium time periods and long time periods. And as you know that long time period is around whenever we talk about sewerage network design and all for a particular project, we usually think of a 30-year period as the timeline when our particular infrastructure that we will design now will be lasting. But as you know that we understand that at the end of 30 years from the base year, we should primarily have a conventional sewerage system, which is the most standard way to actually deal with sewage, and that means it is the most safest way, of course. But it, as we were discussing earlier in our earlier lectures, that sometimes it is not feasible because of financial reasons and because of other reasons as well. So, if sewerage system is conventional system is not possible, then we can go for decentralized system of collection, transportation and treatment and disposal or local use. That means because this is decentralized, that means it done at smaller locality level or at in many smaller points, and both we collect, transport, treat the waste, of course, but we do it locally, and we can do some amount of local reuse as well. So, if we design this kind of a system, we can think of a 15-year period from the base year. That means in the first 15 years we can think about this kind of decentralized system. And if we think about like immediately we have to provide for sanitation and there is now infrastructure in place, then we can even think of shorter time periods of 5 years when we can provide on-site systems. Now, on-site systems are when we provide sanitation just for that particular building and all, and then or maybe a group of buildings, and we are able to treat or dispose of the waste in a proper manner. So, this on-site system, decentralized system and conventional sewerage system are the three options available to us, and we can think of that gradually the city will transition, and along with when the population will grow, and then obviously the taxes and all will be higher, and then we should not be having funding limitations, and then gradually we can at the end of 30 years we can have a conventional sewerage system. But initially we can go for on-site systems, we can go for decentralized systems and so on. So, a city sanitation plan can have an optimum mix of all the three type of system. Even at the end of 30 years, based on the layout of the city, based on the density of population and certain different pockets, based on the contours of the city and so many other reasons, we can have a mix of three systems together. So, it is not like everything has to be converted into a conventional sewerage system, because sometimes it may not be technically the right thing to do as well. So, some of the basic targets, so we should prohibit open defecation by provision of individual and community toilets. So, this is the first point that has to be achieved in an urban area. The first open defecation free that we have discussed in our previous lecture. Then conversion of insanitary toilets to sanitary toilets and provision of properly designed septic tank. So, if there are insanitary toilets in an urban area, that means they have a normal pit toilet, we can make it into a 2-in pit and a pour flush system kind of thing, where some amount of flushing system is involved, and then we also have 2-in pits which are much more sanitary compared to just a single pit system, that I will discuss later on. Then decentralized sewerage system where water is scarce, many Indian cities doesn't have water, so it's better to have a decentralized sewerage system there instead of a conventional sewage system. Then septage or septic tank content management. So this is a big issue in suburban areas and areas which are near rural areas. There may not be a proper municipality, or the urban local body over there may not have the capacity to have the equipment to actually clean the septic tanks and then treat the septic tanks. So that is a big problem that we should take care of, and even in rural areas definitely this is a very big problem. So dislodging, transportation, dislodging is cleaning part of the septic tank or that pit, and or then treatment, and finally disposal. This is what we have to do with the waste that is actually accumulated in our septic tanks, or the sludge that is accumulated in our septic tank. So that treatment has to be there, or there has to be both the capacity of that particular urban body or rural body like a panchayat, that has to have that capacity to provide this kind of services. Otherwise, we cannot have septic tanks in rural areas or this semi-rural areas. So mechanization and safety improvement. So particularly for sewers and septic tank cleaning, so we have to go for more mechanization as per law, as per rules. And then conventional sewerage system. If 135 LPCT is not there, then we have to augment the water supply, otherwise those kind of systems will fail. And recycling and reuse of treated sewage, this is made mandatory now, and provision for public toilets. So these are the different mandates that a city has got that has to be achieved very, very fast to make our cities adhere to ODF, different ODF protocols. So similar to water supply projects and all, whenever we talk about sewage projects, then we need to have a design period, of course. So as you know that in most cases the design period is 30 years, particularly for conventional sewers, but for non-conventional sewers like decentralized system, we can think of design periods like 15 years, then pumping mains 30 years, pumping stations 30 years, civil part, the machinery part is 50 years, that is we can replace pumps and all. Then sewage treatment plants 15 years, because it also involves a lot of machinery. Then effluent disposal 30 years, effluent utilization 15, or as the case may be. So this is the design period which is similar to water supply systems as well. So once our once we have decided on our design period for a particular infrastructure, but before we prepare a sewage projects for any kind of urban area, we need to understand the population forecast for that particular area. So what is, because we are planning not only for today, we are planning for 30 years down the line. So that's why we need to have population forecast for that period, similar to water supply. Then we need to have land use forecast, but because population forecast is not adequate until unless we have the land use forecast both for commercial areas, non-commercial areas and residential areas, we are not able to see that where the infrastructure is required, how the expansion of the network should take place. So we also need to have land use forecast as well. Then city master plan, this is the initial data, because city master plans tells us about the future land use forecast. They tells us about the existing, proposed and the phasing of the different zones. That means which area will be developed first, next and so on. So that is, this information is we get from the city master plans. Then city sanitation plan as per the National Urban Sanitation Policy. So we have to create a city sanitation plan, and we need to create GIS representation of the entire sewerage network, so that it helps not only designing or augmentation of the existing network, but it helps other utility providers and other service providers as well. Then of course we have to go for totally sanitized cities. So once we decide in city sanitation plans for when we create a sanitation sewage project, then we first need to also identify what is our project area. Is it the entire city, or is it a particular zone, or is it a particular catchment? So all these issues needs to be first determined. Or if I have a larger area, how will I break it into catchments or zones and so on. So this depends on the topography, the building layouts, administrative boundaries, economic factors, land use, land cover, the CMP of that particular or the city master plan of that area. So all this determines my project area. Now one issue with sanitation or drainage is the drainage area may extend beyond the administrative boundaries and legal and financial restrictions may prevent extension. So, this is one big issue that we need to be aware of, because of the slope and all, water from adjoining area may come to my area, or from my area it may go to another area. So, this needs to be considered when we design our system. And then for large projects, it may be economical to design sewers considering a certain time frame with additional sewer extensions as and when required. So, it is not feasible to develop the entire network at one go. So, we also need to not only do phasing, but also we think about that, okay, within a particular area or a phase, we need to have extension plans. So, we cannot lay down everything at one go. So, these are the different things that has to be thought of when we decide our project area. So, how do I go about with the city sanitation plan? So, first is the determination of existing needs and demands or deficits. So, first of all, based on for the existing population, what is lacking, what is the deficit, that has to be determined. Then we have to determine that what should be the source of funding for the projects that we are going to propose. Otherwise, there is no point of proposing projects which cannot be constructed. And then other limitations in this regard as well. Then we have to collect a huge amount of data, records, and then we need to understand the status of those infrastructure. Even though the infrastructure is there, maybe it is, it has being fully choked and all. That means we have to totally get rid of those kind of pipes and all, or we have to redo or rehabilitate those particular sewer networks. Then perceptions and expectations of people, these are very important. What people want, how much they want, are they willing to pay for it, all these things needs to be understood. So, this could be achieved some through primary service, some through secondary service or secondary data sources. So, this kind of data collection needs to be there, and it is a huge amount of data is required, particularly for sewerage and drainage. The amount of data required is much more than water supply. And that is one of the also the primary reasons why in Indian cities or in the Indian scenario, we have very poor drainage plans or very poor sewerage plans. The reason is we do not have data, or whenever we are making a project, we do not have funds to collect so much data. So, this is the primary issue that we have seen in many projects eventually. And determination of solutions and technology options, that means which is the appropriate technology for a particular place. So, there could be multiple solutions in terms of technology. So, which one to choose from. And then action plan, step by step implementation strategy with respect to time frame. So, this needs to be sorted out, what comes first, which zone has to be taken care of first, which treatment unit should come first, everything like that. Then take into the stakeholders into confidence, that means consult with all the stakeholders and then propose your plans. So, for example, this is from the CPHEO manual, where you see a decision tree for selecting the technical option for determining if we should go for on-site, decentralized or conventional system for a particular area. So, you will see these terms EWS for economically weakened sections, and then there is something called Baha toilets, which are toilets directly connected to stormwater drains, and non-conventional sewers, simplified sewers, settled sewers and twin drains. So, these are different kind of decentralized systems which we will discuss eventually in. But let us look into this particular decision tree or this flow chart, where you can see that we have city sanitation plan. So, is it for EWS, poor people, or is it for other groups? So, this is the first decision. So, if it is for EWS, we check, are toilets available? If it is no, are toilets plus septic tank affordable by these users? Yes. Then we go for, is collection and disposal to existing sewer? No. Then we go for decentralized system. If it is yes, then disposal to existing sewer networks. Okay. But if are toilets available? If it is yes, then is it unsanitary? If it is yes, then conversion to septic tank, improved septic tank or Jocasso system. Then no, then you can go for community toilets. So, if they are not able to improve from unsanitary to sanitary toilets, then because maybe they do not have the funds and all, then they can go for community toilets as well. So, similarly, if toilets are septic tanks affordable, if not, they can go for community toilets. So, in this way we can have a decision matrix in which you can create your own decision matrix for your own area, and you can determine what sort of system is suitable, right. So, for example, if for others we can have new development or existing development. For existing development, is it on-site septic tank? If it is yes, then we go into this side same way. If it is no, then we can provide septic tank, improve septic tank and Jokaso, and then we again go over here. So, once the treatment part is done, then is the collection and disposal part, which starts over here. And if the sewage, if the sewage volume is greater than 100 LPCD, then and they are willing to pay for it, then they can directly go to conventional sewers. Then we can develop conventional sewage system. So, first of all, we need to have water, as well as people are willing to pay for it, then we can go for this, or we can go into the same decision framework where we ask that if existing sewer or it goes to the decentralized system. So, we can decide on that and then we can do that. So, this is a decision matrix. Again, this is an example. You do not need to exactly follow this, but you can always propose your own decision matrix for a particular urban area. So, what does a city sanitation plan involve? First of all, city sanitation plan is not only the technical document, but also the financing or the documentation, which actually determines that how, not only what kind of investment has to be there, what kind of operation maintenance has to be there, but where do I get the money, how do I arrange all the finances, all these things are part of the city sanitation plan. So, what are the different aspects? First of all, we need to set up a city sanitation task force and implementation agency. So, this is the first job. Then fixing permanent institutional responsibility and sanitation implementation role. So, that means even within a municipal body or a urban local body, we have to have a permanent institutional responsibility and sanitation implementation roles specific only for sanitation and all. We have to set up different groups. And then we can have multi-stakeholder meetings and public resolution and IIC campaigns. And then we can have, based on that, we can also look into the baseline data collection and concurrent use of data in initial action, IIC campaigns and detailed planning. So, we can see about the baseline data collection and then deliberate on those data that we are collecting, and we can talk about what is the existing situation, what needs to be improved and so on. So, that is one. And then we, on the other side, we can look into the legal and regulatory responsibilities, what has to be provided. Technology choices for upgradation, new investment and operation maintenance management. So, what should be the different options? Then operation maintenance service delivery systems, that means what kind of delivery should be there, will it be through PPP mode, will it be through contracts and so on, those kind of things. Then we talk about also special approaches for the poor, then capacity building of that municipal or that ULB or whichever body is actually providing the service, maybe a sanitation board or a water board, and implementation and management and supervision of that finally. And once that is done, then we have to also evaluate and to check the status, what we are able to achieve, and we need to, for that we can have certain rewards at the state level or the city level. That means cities which are able to achieve something, they may get more funding and so on, which is actually does happen. And finally, monitoring of 100% sanitation status. So, more or less this is the different elements of planning, implementation and monitoring and evaluation of citywide sanitation plans. So, when we are talking about monitoring of the sanitation status, we have our service level benchmarks, which we have discussed earlier. So, these are the different parameters which has to be achieved in wastewater management. One is coverage of toilet should be 100%. Coverage of sewerage network services should be 100%, all kinds of network services, decentralized, centralized, maybe on-site and so on. Collection of efficiency of sewage network 100%, adequacy of sewage treatment capacity 100%, everything should be treated, quality of sewage treatment 100%, extent of reuse and recycling 20%, extent of cost recovery in sewage management 100%. So, we need to recover cost, we need to set up user charges so that we can recover cost. And efficiency in redressal of customer complaints 80%, and efficiency in collection of sewage charges 90%. So, that means 90% of service users should be providing money or providing tariff or fees for these services. Everybody should provide, but at least 90% collection efficiency is good enough. So, another major issue of sanitation or sewerage services, sewerage and sewage treatment services in an urban area is of course public health, right. So, sanitation and health are very, very intrinsically linked, and this is the main thing that we are actually trying to protect, that is the health of people living in the urban area. So, we see that 80% of the diseases in human beings are waterborne and water related, and primarily this is because of two things. One is water pollution and the second is water logging. So, both needs to be prevented. So, we need to prevent water pollution, we also need to prevent water logging. So, one term that the World Health Organization used to measure the impact of these diseases, particularly from for any kind of disease, but particularly if I talk about water pollution, that is disability adjusted life years or DALY. So, this is a very, very important term, and which measures the overall disease burden expressed as the number of years lost due to ill health, disability or early death. So, this is expressed in total number of years a person lose in his life. So, in India in 1990 there was a study and the value is in millions of DALYs. That means for the entire urban population, for the entire population in India in 1990. So, now the value would be different of course, but you can see that diarrheal diseases which is primarily related with water. So, you see 14.39 million days are lost by females and 13.64 million days are lost by male. So, this could have been used for so much productive use, right, and we could have generated money out of that. And so, total 28 million days of is lost. And then intestinal helminths, this is around 2, trachoma 0.11, hepatitis 0.31. So, total waterborne and water related diseases comes to around 30.51 million DALYs. So, this is for 1990. Now, what would improve sanitation services mean then? How we can reduce mortality and morbidity? Morbidity is the regular ailments that we have got because of this kind of diseases, and mortality is death, right. So, when we see that if I provide improved sanitation services, again it is very difficult to say what kind of improvement leads to what kind of disease reduction. So, we cannot have a direct correlation and a direct relationship like that, but in general terms based on different studies, based on certain averaging of different studies, we can say that approximately when we talk about morbidity, that is the regular ailments and all, we see that 26% from diarrhea could be reduced, 27% from trachoma, 29% from ascaris, 77% of schistosomiasis, and 78% of dracunculiasis. So, these are the different diseases that could be reduced, and the main thing is the reduction in mortality specific from diarrhea. So, that would be a reduction of 65%. So, we can prevent 65% of the deaths resulting from diarrhea, and reduction in overall child mortality would be 55%. So, these are massive figures, right. So, that means improvement in sanitation services will be able to not only extend the human life, but also you will see that mortality will be also reduced by a large extent. And in terms of cost estimate, the cost of deficient sanitation services cost India around $54 billion, which is around 6.4% of the GDP in the year 2006. So, this is again an estimate. So, you can understand it is a huge, in 2006 terms, $54 billion is a very, it is about 6.4% of our total GDP. So, that is the amount of money we lose in sanitation services cost, and that means if we could have invested even a part of this in sanitation services, then probably we would be reducing this kind of cost that we incur. And $38.5 billion, that is 70% of this is because of diarrhea only. So, that means this is one thing which we can really try to prevent. Next, we will discuss on the different kinds of data and service that we usually collect for this kind of studies or while we prepare sanitation plans. We will also talk about data collected in detail for the drainage plans in later or the stormwater networks later on, but gradually these are the general data that we require. And when we create any kind of sanitation plan or when we need to create a plan for sewage and sewerage and sewage treatment, then these are the data points that we require. And this data is both from secondary sources as well as primary sources. So, all these data sets in these 3 different colors, these are all mostly secondary source data. Let us look at those. We will require data on topography or elevation difference. This actually influences design of sewers, location of STP, outfall and disposal works. So, the entire network design is based on topography. When we talk about urban floods, we need to understand topography or the digital elevation model. So, this is very, very important. Then subsoil conditions, we need to understand the subsoil, what kind of subsoil we have got, what is the amount of moisture in that, all this information is required. Then groundwater, depth of groundwater table and its fluctuation. So, for that we need to do 3 trial bores or 3 trial pits per hectare in absence of data. So, if we are designing this kind of system in an area where there is no data, then we have to go for this kind of actual field service. Then contour map of the area superimposed on the village, town, city maps. Contour map topography and elevation and contour goes hand in hand more or less. So, contour map is required. Earthquake, information about earthquake in this area. Then survey of India maps, land use maps, type or number of industries, which actually determines potential reuse and discharge of sewage. That means not only we will understand what kind of sewage is being disposed, but we can understand can we treat the water for reuse, and if there is some industry willing to take that water, right. So, potential reuse is important. This we will show in case studies later on. Location of streets and adjoining areas, detailed street networks, maps and all. Population density and trends of population growth, historical and socioeconomic data for that area, all these things are important. And then of course, the detailed data on the existing infrastructure. That means underground structures like storm drains and other sewer appurtenances, means the different things like manholes and all these things that are there in the sewer network. Utility services like house connections for water supply and sewerage, electric and telephone cables and gas lines, so that we do not harm them when we create new sewer lines and all. Existing drainage and sewerage facilities and data related to these facilities, effluent disposal sites and their availability. So, these are some of the general data that we require, and of course, if there is a sewerage master plan and related sewerage plans for a particular urban area, we will have that as our secondary source, and we need to, and when we do that, what we will get from that is we will get longitudinal sections and transverse sections of these different channels or streams, both natural and artificial, that is there. So, at certain intervals we take longitudinal sections, like if this is the river, this is the transverse section, and if this is the river goes like that. So, this is the transverse section and this is the longitudinal section. So, for certain segments we take longitudinal sections as well. Then development plans for cities and towns, which gives us this urbanization zone, control area, land use and road network and all the different information on residential and industrial estates and so on, and water supply plans for this particular city. Then when we talk about primary service, some of it could be secondary source as well. Then we talk about sewage quantity, flow and quality of that particular urban area. So, we need to measure the flows in sewers and sewers of similar areas to assess the flow characteristics. Problems like fluctuations, daily fluctuations, weekly fluctuations, peak demand, all these things could be determined. Also, the nature of the sewage that is coming out, what kind of specific gravity, all this information is required. Problems of maintenance of existing sewers, that means we need to survey and see where the choke points are, where people have thrown garbage and it is blocked, and if it is being maintained and so on. Then total pollution load, sewage that is total sewage generated, what is the BOD of that sewage, and accordingly what is the pollution load. Then data on quality and quantity of sewage from large factories, offices, data on wells, data on standard unit pollution loads from different sources, data on existing water quality and flow in water bodies at the time of sampling, data on environmental standards for water quality, then utilization of existing water bodies and future plans related to uses and existing condition and future plans related to water supply. So, we need to understand how the city is planning to augment its water supply, and then how the existing water bodies, what plans do they have, and then we have to relate our sewerage or sanitation plan with this particular existing plans as well. So, in addition to all this, we may try to understand societal preferences and local habits through surveys and all, and then status of institutions and governments, because they are the ones who are going to implement this particular projects and policies. Then survey on treated sewage, sludge and biogas utilizations to understand if there is potential for reuse and all. So, sewage could be used in development of forestry, green belt development, lawns in road medians and so on. So, we need to find uses for treated sewage. Sludge could be directly used in farm forestry as an alternative energy source in biomethanation and as a construction material even. So, this is, we have to also, if we want to treat sludge, process it, then we may also try to find options to reuse that, so that it becomes economical to a certain extent, or we can recover some of those charges. So, reuse of treated sewage to a minimum extent of 20% by volume. So, reuse, this is mandatory, 20% of this is mandatory, which we have already discussed in the service level benchmarks. So, these are the technical part, but we also need to understand the other aspects, the fiscal aspects particularly related with the ULB, because it is the ULB which is going to implement this kind of infrastructure or projects. So, the existing loans, commitment and policies of the ULB needs to be looked into, and this will affect the financing of new projects. Then government loans, granting aid, loans from banks and institutions like LICs, Industrial Development Corporations, HUDCO, International Bank for Reconstruction and Development. So, these are the different banks which gives loans and all, long term loans in smaller interest rates for this kind of projects. Then present tariff and recovery of charges from different category of consumers. Then general capacity of community to pay for this kind of services. If the community is not able to pay, no point in providing a very good service, very higher efficiency service, because nobody is going to, because it is not going to be maintainable in the longer term. Then cost of construction, operation and maintenance, taxes, levies, acts and rules. So, these are the different aspects or the guiding principles or of that particular ULB that we need to be aware of, or of that particular state maybe as well. So, in addition, there are other issues such as administrative boundaries and merger of adjacent communities, because sometimes it actually helps in designing the networks. Then feasibility of multi-regional or multi-municipal system, because as we are discussing, water from one zone may go into another zone or in another municipality. So, if a multi-zone system or a multi-municipal system is actually looking into the sewerage network for this entire zone, probably it will result in more efficient services. So, to conclude, city sanitation plan should be developed considering an optimum mix of on-site, decentralized and conventional sewerage systems. The cost of sanitation should be equated with health, then only we can justify many of the cost of the building this kind of infrastructure. A wide variety of data is required for preparation of sanitation plan, which sometimes poses a big challenge, particularly in the Indian context. So, these are some of the references you can study. Thank you.